Good morning, students. So, welcome to our new lecture. In this particular lecture, we are going to see the uses of properties of parallel lines. Okay. So, in the previous lecture, we have seen the practice set 2.1. We have studied about the properties of parallel lines. We know about the corresponding angle property. We also know about interior angle property and alternate angles property. Okay, so by using those properties, what else we can prove in the field of geometry, we are going to see that in this particular chapter. Okay, so in this lesson we are going to deal with that particular point. Now we all know that sum of the measures of all angles of a triangle is 180 degree. So in any triangle, if we take the measurement of all the angles, okay, if we take the sum of the measures of all the angles, what we are going to get? We are going to get 180 as an answer. Okay, so that means angle A plus angle B plus angle C is equals to 180 degree. So we all know this about this particular property of a triangle. So we are going to prove this particular property by using some properties of parallel lines. Okay, so what is the statement of the theorem? The sum of measures of all angles of a triangle is 180 degree. Okay, so we have taken a triangle, that is triangle ABC. Okay, and what we have to prove? We have to prove that angle ABC, that means this angle, okay, then plus angle ACB, that is this angle, okay, and angle BAC, that means this angle. So the sum of all these three angles is 180 degree. We have to prove this. Okay. So for proving this particular theorem, we have to do certain construction work. Okay. So what I am going to do, I am going to draw a line, okay, PQ, which is going to be parallel to side BC of triangle ABC. Okay. And this line PQ is going to intersect point A of the triangle. Okay, the vertex A of the triangle. So I have drawn a line over here, which is line PQ. Okay, and it is passing from point A, and the collinearity of the point is in such a way that is P is first, then A is in between the P and Q is the last point in the line. Okay, now how we can prove this particular theorem? Now we have taken that PQ is parallel to BC. Okay. So this is from the construction work, that line PQ is parallel to side BC of triangle ABC. And first I'm going to take AB, okay, this particular line AB as my transversal. So in that case, this angle, that is angle PAB, this angle PAB is equal to angle ABC. As we all know, whenever two lines have a transversal, okay, and obviously the alternate angles are going to be equal in that case. Okay, so this angle PAB and angle ABC, both are the interior alternate angles and both are equal to each other. Okay, so I have written this down. Angle ABC, okay, angle ABC is equal to angle PAB, okay, by alternate angles. Okay, then again I will take line PQ and line BC, okay, as parallel lines, but in this time I'm going to take segment AC as my transversal. Okay, now this is the transversal, that is segment AC. Now in that case, this angle, that is angle QAC and angle ACB. Okay, QAC and angle ACB are equal to each other. Why they are equal? Because again, both the angles are interior angles. Okay, angles. So we have written this angle ACB is equals to angle QAC. Okay, these are interior alternate angles. Okay, so the reason is alternate angles. Now what I will do, I will add equation 1 and equation 2. So the left hand side of equation 1 is going to be added to the left hand side of equation 2, and the right side of equations are going to be added on the right side. So angle ABC plus angle ACB is equal to angle PAB plus angle QAC. Okay. So this is what we have written here now. This is our equation number 3. Now what I will do, I will add angle BAC on both the sides. Okay. Now if I am adding angle BAC only on the one side, okay, that is LHS, and I am not adding this particular term on the RHS, then my equation is going to be wrong. Always remember that whenever we take an equation that is A plus B is equal to, suppose, D plus E. Okay. Now if I want to add a particular term on the left hand side, so that same term must be added on the right hand side as well. So if I want to add C in the LHS, that means I have to add C in the RHS also. Okay, so here I want to add angle BAC and I am adding that angle BAC on both the sides. Okay, so I have got angle ABC plus angle ACB plus angle BAC. Okay, so we have got our LHS, I think so. Okay, we have got our LHS. Now in the RHS we have angle PAB plus angle QAC plus angle BAC. Okay, now angle PAB, okay, this angle PAB and angle BAC, this angle. Now both this angle PAB and angle BAC, okay, can be written as angle PAC. Okay, so PAB plus BAC क्या होगा, ये एंगल और ये एंगल का एडिशन करेंगे तो हम लोग क्या मिलेगा, एंगल PAC मिलेगा. Okay, so I have written that angle PAC over here. Okay, and we have left angle QAC as it is. Now angle PAC plus angle QAC, that is this angle, okay, plus this angle, both the angles, if we take the addition of both the angles, what we are going to get, we will be getting 180 as answer, 180 degree. Why the answer is 180 degree? Because these angles are in linear pair. So we know whenever angles are created from a single point on a line, then the sum of those angles is going to be supplementary. Okay, though the number of angles may vary, but if the point is same and n number of rays are emerging, then also for a line the sum of all those angles are going to be 180 degree. Okay, so we have written here angle ABC plus angle ACB plus angle BAC is equals to 180 degree, and by this way we can state the proof, theorem, that is sum of measures of all three angles of a triangle is 180 degree. Okay, so this is the proof for this particular theorem. Okay, now we will see certain tests of parallel lines. Okay, we will see how we can inspect or how we can find out whether the given pair of lines are parallel to each other or not. Okay, so there are certain tests. So we'll start with the very first test, and that test is interior angles test. What is the test? Interior angles test. Okay, so we know whenever two lines are parallel to each other and a transversal is passing through it, the interior angles are going to be supplementary. Okay, so by using that property we are going to prove this theorem. So what is the statement of the theorem? If the interior angles formed by transversal of two distinct lines are supplementary, then the two lines are parallel. So it is given in the statement that if there are two lines, okay, two distinct lines, and a transversal is crossing them, okay. So if the interior angles are supplementary, sum of the interior angle is supplementary, then both the lines are parallel. We have to prove this. Okay. So how we can prove that? First of all, we will take the given terms. Okay, we have taken AB and CD, okay, as two lines, and we have taken xy as our transversal. Now in this case angle BPQ, that is angle BPQ plus angle PQD, okay, what we have to prove, what is the term that, okay, what we have to prove that these two lines AB and CD are parallel. And what is the given data? That interior angles are supplementary. So angle BPQ plus angle PQD, the sum of these interior angles, okay, it is 180 degree. Okay, so we have to prove that AB is parallel to CD. So how we can prove that? We are going to give an indirect proof. Okay, to solve this particular theorem, we will be having an indirect proof. Let us suppose that the statement to be proved is wrong. In the beginning, we are going to suppose that line AB is not parallel to line CD. हमें प्रूफ क्या करना है कि लाइन AB और CD पैरेलल है, लेकिन हम लोग इसको डायरेक्टली प्रूफ नहीं कर सकते हैं, इसलिए हम लोग क्या लेंगे कि लाइन AB और CD एक दूसरे को पैरेलल नहीं है, ये हम लोग सबसे पहले कंसिडर करेंगे। ओके, सो अगर लाइन AB और CD एक दूसरे को पैरेलल नहीं है, इसका मतलब क्या है कि वो दोनों किसी एक पॉइंट के ऊपर इंटरसेक्ट होंगे। ओके, अगर ये लाइन और ये लाइन एक दूसरे को पैरेलल नहीं है, इसका मतलब क्या है कि ये लाइन एक दूसरे को किसी न किसी पॉइंट पर क्या होने वाले, इंटरसेक्ट होने वाले। ओके, सो हम लोगों ने क्या कंसिडर किया है कि ये दोनों लाइन ए बी और सी डी ये इंटरसेक्ट होंगे पॉइंट टी के ऊपर। किसके ऊपर इंटरसेक्ट होंगे? पॉइंट टी के ऊपर वो क्या होंगे, इंटरसेक्ट होंगे। ओके, so this is our assumption. Now, after considering the intersection, okay, of AB and CD at point T, we can take triangle PQT. Okay, triangle PQT. So, as it is given to us that, as we all know, that the sum of the all angles in a triangle. Okay, in this particular theorem we have seen. So in this theorem we have seen the sum of measures of all angles of a triangle is 180 degree. That means angle QPT, okay, or angle TPQ and angle TQP and angle PTQ, all these three angles are going to have the sum equal to 180 degree, as sum of angles of a triangle is 180 degree. Now what is given to us that angle TPQ plus angle PQT, this angle TPQ plus angle PQT, okay, these angles are the sum of this angle is 180 degree. This is the given data to us. Okay, so that is the sum of two angles of the triangle is 180 degree, but sum of three angles of a triangle is 180 degree. So angle PTQ is equal to 0 degrees. Now हमें गिवन में क्या दिया हुआ है कि ये जो एंगल है और ये एंगल, एंगल पी और एंगल क्यू दोनों का एडिशन क्या है हमारा, 180 डिग्री आएगा। तो हम लोगों ने क्या किया, एंगल पी और एंगल क्यू दोनों का एडिशन किया तो 180 आ गया। तो हम लोग को इक्वेशन क्या मिला, 180 प्लस एंगल पी टी क्यू के एंगल पी टी क्यू मिल गया, इज इक्वल टू क्या मिला हम लोग को, 180 मिल गया। Now this 180 from the LHS and this 180 from the RHS is going to be cancelled. So we get angle PTQ is equals to 0. क्या मिला हम लोग को angle PTQ? It is equals to 0. Okay. So as angle PTQ is equals to 0, what we can write, that line PT and line QT means line AB and line CD are not distinct lines. Okay. But we are given that line AB and line CD are distinct lines. So we arrive at a contradiction. So as we have got angle PTQ is equals to 0, okay, so that means that this line AB and CD are not going to intersect each other, okay, as this angle is 0 degree. So we are going to write that line PT and line QT means line AB and line CD are not distinct lines, okay. But what we have taken our assumption was that they are distinct lines, okay, and they are going to intersect each other. But after getting this angle PTQ is equals to 0, our assumption has been proved wrong. Our assumption is wrong. So we can write that line AB and line CD are parallel to each other. And hence we have got the proof that the interior angles formed by a transversal are supplementary. And if the interior angles are supplementary, then we can write that those lines are parallel to each other. Okay, and this particular property is called as interior angles test. Okay, it is called as interior angles test. Now we will see alternate angles test and corresponding angles test in the next lecture. Okay, so for this lecture your homework is going to be, you have to write down the theorem. Okay, this theorem, that is the sum of measures of all angles of a triangle is 180 degree. So you have to complete write down this particular theorem with its proof, okay, along with all this diagram in your notebook. Okay, so we will meet in the next lecture. Until then, goodbye.